Hi everyone, it's Ms. Costa here, and in this video we're going to go through some revision and recap for the Core 2 Unit 1, which focuses on number. So here you can see all of the topics, and when you feel confident with them you can tick them off as completed. Okay, so first we've got a non-calculator method which is called doubling and halving, and this comes in really handy when we're doing any kind of multiplication and we don't have a calculator near us. So if I double one part of the calculation and halve the other, my answer will be the same. Let me just show you. So here I've got 10 times by 8, let's say. If I doubled that, so let's say I doubled 10, that becomes 20, and I halve 8, that would become 4. Let's have a look at what happens to the answer. So 10 times 8 is 80, and 20 times 4 is also 80. So what that shows me is that whenever I've got a calculation and one part, if I doubled it, it would make my calculation a lot easier, I can use this method. So let's see how it would apply. So 45 times by 8 seems a little bit tricky, but if I perhaps doubled one of these numbers to make it maybe a multiple of 10, and I halved another one, it might become a little bit easier. So 45 doubled becomes 90, and 8 halved becomes 4. 9 times 4 is 36, and I add the 0. So I know that 45 times 8 must also be 360. Let's try again with 35 times 6. Well, 35 seems like a little bit of a tricky number, so if I doubled that, that would become 70. And because I've doubled the first part, I'm going to need to halve the next part. So 70 times 3, or 7 times 3 is 21, and I add the 0. Then I've got 15 times 14. So again, let's see what I could do. If I doubled 15, that would become 30. And if I halved 14, that's 7. And then 3 times 7 is 21. So that would also be 210. So now you're starting to get the picture. It's really handy as long as you can remember this trick. And especially when we've got decimals. Multiplying by decimals can sometimes be tricky. So if I know that if I double something, it will become a whole number, that can make my life a lot easier. So a 2.5, what I can do is double that. That would be 5. And then I'm going to have to halve 18. 5 times 9 is 45. So with the decimals, that's one of the key tricks. If it ends in 0.5 and you double it, it's going to become a whole number. So 3.5 doubled is 7. And 7 times 8 is 56. 6 times 8.5, well, I'm going to want to double the 8.5, so that means I'll halve the 6, so that would become 3 times 17, which is not super easy, so we might want to use multiplication. So I do 3 times 7, which is 21, 3 times 1, which is 3, and I add the 2, so that would become 51, but it's still easier than doing 6 times 8.5. Then I've got 4.5 times 18, so I'm going to want to double the 4.5, that would become 9, and halve the 18, which becomes 9, so that becomes 81. And finally, I've got 22 times 1.5, so I'm going to want to double the 1.5, so that would become 11 times 3, which is 33. Okay, so now just a brief recap on adding decimals. Now the key thing you want to do when adding decimals is to make sure that your decimal point is lined up. If that happens, then you're pretty much set. So here I've got 0.08 plus 0.32. So the key thing is I want to make sure the decimal points line up and all the digits after the decimal point are lined up in the same column. So 0.08 plus 0.32, I can just use the column method now. 8 plus 2 is 10, 0 plus 3 is 3 plus 1 is 4. So if I added these together and 0 plus 0 is 0, that would give me 0.40, which is the same as 0.4. Next, I've got a 3-part calculation. So with a 3-part calculation, don't try and add it all at the same time. Just do the first 2 parts of the calculation, and then once you've got your answer, do the final part. So we've got 21.7 and 1.08. So take note of how the decimal points are lined up. And if your number runs out of digits, just add a 0 because that has the same value. So 21.70 plus 1.08, 0 plus 8 is 8, 7 plus 0 is 7, 1 plus, put the decimal point in, 1 plus 1 is 2, and that would be 22.78. I then do the next part of the calculation. I'm going to add 0.46. So 22.78 plus 0.46. 8 plus 6 gives you 14. 7 plus 4 is 11, plus 1 is 12. 2 plus 1 is 3. So that would be 23.24. And then we've got a subtraction. So this, we can use the column method for subtraction as well, as long as my decimal points are lined up. So I've got 7.9 take away 2.56. So remember, especially with subtraction, it's really important you include the 0. Otherwise, it's very easy to get confused. So here I've got 0 take away 6 is going to be the first part that I want to do. Now I can't do 0 take away 6 because that's going to give me -6. So I'm going to have to borrow from the number next door. So I take 1 from that, that becomes 8, and I add it over here. So that's now 10 take away 6, which is 4. 8 take away 5 gives you 3, put the decimal point in, and 7 take away 2 gives you 5. So that would be 5.34 for the first part. Now with this, I'm going to do 5.34 take away 0.765. Again, I've run out of numbers on my first number, so I'm going to have to put a 0 there. So then I do 0 take 5. Again, I can't do that because I'll go into the negatives. So I'm going to have to borrow from the 4, take 1 from there, that becomes a 3, and that becomes a 10. 10 take away 5 is 5. 3 take away 6, again, I can't do. So I'm going to borrow from next door, take 1 from that, so that becomes 2. Add it to the 3, so that's 13 now. 13 take away 6 is going to give me 7. 2 take away 7, again, I can't do, so I'm going to borrow from next door, and that's going to become 12 take away 7, which is 5. And then 4 take away 0 is 4. So a slightly tricky one, but remember, if you run out of digits, just add a 0 so that you're subtracting from 0, because you need to maintain the same place value, and make sure that your decimal points are lined up. Okay, so now a recap on the bus stop method. So this is when we were dividing by a single digit number. It's really, really handy. So we've got 435 divided by 3. Now, some people sometimes get confused which number goes first, and they think it's always the biggest number. I mean, quite often that's the case, but that's not what goes in first. The reason it's called the bus stop method, or one of the reasons, is because let's just imagine you're a number, and we live in England where, I mean, right now it's raining, so the probability of it raining is probably quite high. The first person that gets to the bus stop is the one that gets to wait under the bus stop. So 435 arrived first, so it gets to wait under the bus stop. 3 came later, so unfortunately it gets rained on and it has to wait outside. So the number that goes inside the bus stop is the number that is being divided by, and that's the number that is first. Okay, so here we're going to have my bus stop. I'm going to have 435 on the inside and 3 on the outside. Then what I do is I say to myself, how many times does 3 go into 4? 3 goes into 4 once, because the 3 times table is 3, 6, 9, 12, and 4 would be here, so one lot of 3 fit into it. And there's a remainder of 1. Then I think, how many times does 3 go into 13? Well, that's 1, 2, 3, 4 times, with a remainder of 1. And how many times does 3 go into 15? 3 times. So therefore 453 divided by 3 is 143. Now let's do the same with the next question. 568 divided by 4. So 568 goes inside the bus stop because it got there first. And then I think to myself, how many times does 4 go into 5? That's once, with a remainder of 1. How many times does 4 go into 16? 4 times. How many times does 4 go into 8? Twice. So 568 divided by 4 is 142. Okay, so now I've got the bus stop method with some decimals, and I'm using the exact same method. So 36.82 is the number that arrives first, so it gets to wait inside the bus stop. 4 goes in the outside. I think to myself, how many times does 4 fit into 3? Well, it doesn't, because the first number in the 4 times tables is 4, and 3 is less than 4. Therefore, there's a remainder of 3, because none of that 3 gets used. So I put 0 here, and I put the 3 next to the 6. How many times does 4 go into 36? Hopefully you know your 4 times tables. If not, and if you get stuck, just write out the times tables for yourself. Just keep on adding 4, and then you can figure it out. So 1, 2, 3, 4, 5, 6, 7, 8, 9. I know that 4 goes into 36 9 times. I'm going to line up the decimal point so it stays where it is. And then I say, how many times does 4 go into 8? That's twice. How many times does 4 go into 2? Well, it doesn't, because 2 is less than 4. And this is where it gets tricky. Well, not tricky if you know what to do. So when you run out of digits, you add a 0 at the end. Okay, you can add multiple zeros because we don't know how much of my number is going to run out. But I'm going to carry that. So I know that 4 doesn't fit into 2, so there's a remainder of 2. So it now becomes how many 4s fit into 20, and that's 5. And that's gone in perfectly, so I know that that is my full division. So 36 divided by 4 is 9.25, 205. And for the last one, we do the same thing. So 56.82 divided by 6. So how many times does 6 fit into 5? It doesn't, so that's 0. I'll carry the 5. How many times does 6 go into 56? Again, if you're stuck, then write out your 6 times tables. But we might think to ourselves, 6 times 10, I know is 60. So then 6 times 9 must be 54. So you can work backwards that way too. So I know 6 times 9 is 54. So there's going to be a remainder of 2. I put the decimal point. Then I think to myself, how many times does 6 go into 28? Well, I know 6, 12, 18, 24. So that's going to be 4 times with the remainder of 4. Because from 24 to 28, there's 4 left over. And for the last bit, I just say, how many times does 6 go into 42? And again, if you don't know, write out your 6 times tables, but it would be 7. So that is the key thing for division. Make sure that the first number goes inside the bus stop. And if you run out of digits at the end, just add zeros. Okay, so negatives are one of the really, really, really important parts of maths that keep coming up in so many different topics and subjects. So it's really important that we try and master this. And whenever I'm dealing with adding or subtracting a negative number, what I want you to do is just picture a number line, like a thermometer, something telling the temperature, how hot or how cold something is. So wherever you are, either visualize it in your head or just draw a quick sketch for yourself. It doesn't need to be a long number line, but just have this visualization in your head. So the number line, the higher up it goes, the warmer the temperature, the larger the number. The lower down it goes, the colder it is, and the smaller the number. Now, if I'm adding, I'm making the number larger. So if I'm adding, I'm always going to move up the number line. And if I'm subtracting, I'm always going to move down the number line. Okay, so that's the key thing that we want to remember and apply to with any negative numbers. Now, the next bit that gets a little bit confusing is when we've got 2 signs next to each other. So once again, if we imagine, in this case, let's imagine like a soup. So you've got a soup and it's currently 3 degrees. And then someone's like, oh, I want to make it colder. So I want to add more ice cubes into it. And an ice cube can represent a negative number. It's going to cool it down. So when I'm adding a negative, what's actually happening is the temperature getting higher or lower. Well, if I'm adding ice cubes, so adding a negative is going to make it colder. So whenever I'm adding a negative, and you've got 2 signs here, it's always going to become a negative. So adding a negative is the same as just subtracting. So whenever you see 2 signs in the middle, and it's one of them is plus and the other is minus, I want you to circle it and rewrite it as a minus, because that will help make your calculation a lot simpler. And then you're left with 3 minus 9. So 3 on the number line would be here, and I'm subtracting, so I know I'm going to go down the number line. If it helps, then literally draw out the number line from positive 20 to negative 20, and then you can just count up on it. So from 3, I'm going to go down 9. So it'll go 1, 2, 3, 4, 5, 6, 7, 8, 9. So 3 take away 9 would be negative 6. Next, I've got 4 plus negative 3. Again, I've got two signs, a positive and a negative, in between my numbers. So when I'm adding a negative, it's the same as subtracting. It's making it colder. So I'm going to recircle it and rewrite it as 4 minus 3. And then I can look at my number line again. I'm going to start on 4 and I'm going to subtract 3. So I go 1, 2, 3. So 4 minus 3 is going to be 1. Now, if we think back to the little soup that we're having, and let's say it's 7 degrees, and it's 7 degrees because someone's put loads of ice cubes in there and they've made it cold. But you're like, oh, I don't like my soup cold. So you take out the ice cubes. So you're subtracting a negative. You're taking out the ice cubes. And what's going to happen? Eventually, the soup is going to warm up because you're taking away the coldness. So if I'm subtracting a negative, the effect that has is that it actually makes it positive. So if you see a negative and a negative next to each other, I want you to rewrite the signs as a positive. So subtracting a negative makes the number larger. So 7 take away minus 8 is the same as 7 plus 8, which is 15. So again, over here, I've got 4 minus 6. That's two negative numbers, negative signs next to each other. And subtracting a negative is the same as adding. So that's going to be 4 plus 6, which is 10. Then it gets slightly trickier because we've got the double signs and we've got negatives. So first step, I'm going to rewrite because I see that there are two signs here. So adding a negative is the same as subtracting. So it would be minus 3, minus 9. So you think, okay, I'm going to start at minus 3 on the number line and I'm subtracting, so it's going to go down the number line. So minus 3, minus 9. And either you do this on the number line, or another little trick is, if you're dealing with negative numbers, so let's do an easy one. Minus 1, minus 2. Over here, minus 1, minus 2 is going to go minus 1, minus 2 is going to be minus 3. And if I had 1 plus 2 over here on the other side, because it's like a mirror reflection, I had 1 plus 2, that would go up to 3. So if it's a negative number, take away a number, it's the same as a positive number adding that number. But that's a trick that you don't necessarily need. Just if that makes sense to you, use that. If not, until you get the confidence, use the number line. And think to yourself, I'm subtracting, so it's going to have to go down the number line. And when we're going down the numbers, down the number line, the numbers actually get larger. So minus 3 minus 9 is going to be minus 12. Because if I think to myself 3 plus 9 on the other side, on the positives, that would give me 12. Okay, next I've got minus 4 plus minus 3. So again, it's a plus and a minus. When I'm adding a negative, it's the same as subtracting. So it's going to be minus 4 minus 3. Now this one I could probably demonstrate on the number line. So minus 4, I know I'm going to go down. So I'm going to go 1, 2, 3. And that would take me to negative 7. Similarly, because it's a minus number, take away a number, it's going to be the same as the positive version. So 4 plus 3 is 7. So you can help and use that trick that way. Then we've got minus 7 minus minus 8. So again, I see the two signs in the middle. I'm going to rewrite them as a positive. Taking away a negative is the same as adding. It makes it warmer if we think back to the soup. So minus 7 plus 8. So think you're going to start minus 7 on the number line and you're going to add 8. So if minus 7 was here, we're going to go from minus 7, 1, 2, 3, 4, 5, 6, 7, 8. Which is going to be positive 1. Finally, we've got minus 4 minus minus 6. Taking away a negative is the same as adding. So that would become minus 4 plus 6. So again, we can look on our number line. We've got minus 4, 1, 2, 3, 4, 5, 6. If you're not super confident on negatives, I would really encourage you to draw yourself a number line and see if you can use that trick when it's a negative number taking away a negative. Okay, so next we've got multiplying and dividing with negatives, and these have different rules to adding and subtracting. So adding and subtracting, the number line is perfect and we want to use that as much as we can. And with multiplying and dividing, we just have to think a little bit differently. So we've got multiplying a negative. So sometimes it helps if you think of negatives as if you've ever been to the beach and you might have made a sand castle, so that's like a positive number, and you might make a little hole in the sand to like dig a moat around the castle or something. So a negative number is a hole in the ground, it's negative, and a positive is like a little bump above the sand. And then you've got 0, which is the flat line of the beach. So if I'm doing 3 times negative 9, I've basically dug 9 holes into the ground. 1, 2, 3, 4, 5, 6, 7, 8, 9, and I want 3 lots of these. So I'm going to do 3 times, imagine it's a positive number, 3 times 9 is 27, but it's a negative number, so 3 times minus 9 is going to be minus 27. So when I'm multiplying and only one of my numbers is negative, the answer is always negative. Again, I've got 4 times by minus 3. So we can maybe visualize this one a little bit better. So this is minus 1. And altogether, that's going to be negative 3 holes in the ground. And if I want 4 lots of this, I'm going to draw another 4 of these. So in total, what happens? I've got 12 holes in the ground. So 4 times minus 3 would be negative 12. When I'm multiplying by a negative number, the answer will be negative. It gets a little bit trickier when I've got when I'm multiplying by a negative, and there's no super great way to explain why this is. We just have to remember that a negative multiplied by a negative is going to give me a positive answer always. Okay, so if the signs are the same, so if both of your values are negative or both of them are positive, your answer is always going to be positive. So they're both negative, so I know it's the same as multiplying positive numbers, and 7 times 8 is 56. Okay, so that's a nice little trick. If the signs are the same, then the answer is going to be positive. So let's try it again. I've got minus 4 times by minus 6. Well, the signs are both negative, so that's the same as if I was multiplying the positive versions, and 4 times 6 is 24. Then I've got minus 9 divided by minus 3. Now these rules apply for division as well. So I've got 2 negative signs. The signs are the same, so therefore the answer is going to be, positive. So minus 9 divided by minus 3 is the same as 9 divided by 3, which is 3. Then I've got minus 4 divided by 2. So because only one of them, so the signs are different, the answer will be negative, but let's see if we can understand why. So again, if I had 4 buckets in the sand, or 4 like holes, moats, or whatever you want to call them, and I divided it by 2, what dividing by 2 means is I'm splitting it in half. So someone came away and was like, hey, you're greedy, I want to split this in half. Then what happens? Minus 4 divided by 2 becomes 2. Just, well, negative 2. You're left with 2 of the holes in the ground. So it's the same as with multiplication. The answer is going to be negative. Minus 4 divided by 2 is just going to be minus 2. Again, you can think to yourself, what would 4 divided by 2 be? That would be 2. One of the signs is negative, so the answer is going to be negative. Okay, I've got minus 49 divided by minus 7. Think to yourself, the signs are the same, so the answer is going to be positive. So that's the same as saying 49 divided by 7, which is 7. And then again, I've got minus 24 divided by minus 6. The signs are the same. They're both negative. A negative times by a negative, or a negative divided by a negative, is always going to give you a positive answer. So that's the same as saying minus 24 divided, I meant to say 24 24 divided by 6, which is 6, 12, 18, 24. So that's 4. Okay, so a little bit trickier here, but just remember, if the signs are the same, the answer is going to be positive. If the signs are different, the answer will be negative. And this is just for multiplying and dividing. For adding and subtracting, you use the number line and you go up or down. Okay, so here I am going to have to do some substitution. Now, substitution is when you are given a value of something, and it's going to be a letter, and all the letters in algebra represent our values that we don't know, but sometimes they tell us what that value is and we can work it out. So I need to substitute the values into each formula and work out the answers. Now I'm told that A equals minus 4B. What I want to always do is think to myself, what is the algebra doing? Now in algebra, when a number and a letter are next to each other, they're like attached by invisible algebraic multiplication glue. Okay, so whenever they're next to each other, that means they're being multiplied. So I can actually rewrite that for myself to just make it a little bit easier to explain what is actually happening. Minus 4b means minus 4 times by b. Now, I don't know what b is, but I've actually been told that I want to find out what the answer to this would be when b is negative 7. So what I'm going to do is substitute negative 7 for where I see the letter b. So minus 4 times by minus 7. Now, the reason I said to be careful with the algebra is because some people sometimes say, okay, I just need to substitute, so I just need to put a negative 7 where there's a b. And what they do is they'd say that's minus 4 minus 7, but that doesn't really make sense. And the reason it doesn't make sense is because it's ignoring what the algebra is actually doing. When a number and a letter are next to each other, they're being multiplied. So we've got A is minus 4 times by minus 7. And what happens when I multiply two negative numbers by each other? They become a positive. So remember that key rule. A negative times by a negative is going to give you a positive answer. So then I've got 4 times 7 is 28. So the value of A is 28. Now let's do the same for the next question. We're told that A equals 3B minus 1. Now what happens when a number and a letter are next to each other? There's the invisible multiplication glue. So that actually means A is 3 times B, and I can put brackets in it because they're attached, so they have to be together. They come first. So that's 3 times B, take away 1. The brackets just tell me that I have to do that bit first. Otherwise, I might get confused and do B take away 1 first. So what is the value of B? They've told me B has a value of negative 6. So that's going to be 3 times by negative 6. And then I'm going to subtract the 1. Now, what's 3 times negative 6? Well, the signs are different. So remember, when it's negative times by a positive, the answer is negative. So if the signs are different, the answer is always going to be negative. So 3 times 6 is 18. So 3 times minus 6 is going to be minus 18. Now I've got minus 18 minus 1. So using my number line, I go to minus 18 and I'm subtracting. So I know it's going to go down. So you can imagine it's going to get colder. So it's going to be minus 19, because when you're subtracting, you go down the number line. The numbers get like larger, but they're actually getting smaller, like in terms of value. Okay, so over here we've got A is minus 19. And then for the last bit, we've got quite a tricky one because we've got 2 parts that need substitution. So P equals 7R, and okay, I should know by now when a number and a letter are next to each other in algebra. By next to each other, I mean literally next to each other, attached. It means they're being multiplied. So that means 7 times R. I'm just going to put it in brackets to show that that has to be done together. Take away 3 times Q. 3 lots of Q. Okay, so P is going to be, what's the value of R? Negative 5. 7 times by negative 5. Take away, the value of Q is minus 3. 3 times by minus 3. So let's work those out individually. 7 times by negative 5, well, 7 times 5 is 35. 7 times negative 5 will be negative 35, because when the signs are different, the answer is going to be negative. And then I'm going to take away 3 times minus 3. 3 times 3 is 9, so 3 times minus 3 is going to be minus 9. And now here, looks a little bit tricky because we've got these two signs here. Hopefully we remember from what we just did, when a negative and negative are next to each other, we rewrite it as a positive. Taking away a negative, remember from the soup, when we're taking away a negative, we're making it warmer. So that would become minus 35 plus 9. And this bit is a little bit tricky. So we've got minus 35 and we're adding 9. It's the same as if you think about it, it's like a mirror reflection. So minus 35 plus 9 is the same as 35, positive 35 minus 9, which would be 26, negative 26. This one is tricky if you don't have a number line. So I think it would be a calculator question maybe, but if it's not, maybe just draw yourself a number line if you're really stuck, or try and think of the mirror opposite. So remember, with a mirror opposite, you've got minus 35 here, and you're adding 9, you're getting closer to the number line. So that's the same as if you had 35 here and you were subtracting, because you're doing like the mirror opposite. But that method is a little bit tricky to understand. But that's how we'd do that kind of question. Okay, so here we've got a reintroduction to the square numbers. So hopefully you've come across them and you know why square numbers are called square numbers. But if you don't, just a quick little recap. Square numbers are called that because if we literally multiply them, they kind of form a square. So let's start with 1. I draw a square of 1. Well, 1 times 1 is just 1. If I then drew 2 squares by 2 squares down, what actually happens? Well, 2 by 2 gives me an area of 4. So the second square number is 4. Again, if I did it with 3, I've got 3 times by 3 down, fill in everything else to make it a square, and 3 times 3 becomes 9. One last one, we've got 4, so we've got 1, 2, 3, 4, down by 4, and I fill in all of the other squares to make it a full square. So 4 times by 4 gives me 16, okay? And they're the first square numbers. So a square number is just a number multiplied by itself. And the way we write a square number is with this little indice there. So 1 squared, this little 2 means squared. And squared means multiplied by itself. And the reason they're called square numbers is when you multiply anything by itself, so like a length times by width, it's always going to be a square number. Okay, so with that in mind, let's think to ourselves, we've got 3 squared plus 2. Now, if you didn't know the square numbers, I have written them out here for you, and I would really encourage you to memorize them. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, and so forth. Okay, so you should know these off by heart. If you don't, write them down, put them on a post-it note somewhere and just repeat them to yourselves. Or actually, better still, to memorize them, just draw out the squares. You just need to do it up to 12. Get a book, and maybe every day for a week, draw out the squares. So you're like, 1 square by 1 is 1, 2 squares by 2 squares is 4, and so forth. And then do it for a week and it's going to sear itself into your memory and you're going to remember the square numbers forever. But the reason they're called square numbers is because when you multiply anything by itself, it will form the shape of a square, which is pretty cool, really. So 3 squared, what does that mean? It means 3 times 3. So I'm going to do 3 times 3, and then I'm going to add 2. You might already know 3 squared is 9, in which case you would have just done 9 plus 2 and figured out that is 11. Okay, 5 squared. I'm not going to write it out because I'm going to assume you stopped the video, drawn out the squares, and now the square numbers are seared into your memory. So 5 squared is 25. So I've got 25 plus 7. 25 plus 7 is going to give me 26, 27, 28, 29, 30, 31, 32. If you're getting a little bit overwhelmed and you're like, oh my gosh, there's so much maths, my brain is full, just use your fingers for like small additions and subtractions. Next, we've got 4 squared times 2. So what do? Now, we have to use the... oh, do we have BIDMAS coming up later on? I think BIDMAS is something that we should have already done. So, just a quick little recap. When we've got BIDMAS, we do anything that's in brackets, we do that first. Anything that's in indices, so something like 4 squared or 3 squared, that's the second thing we do. Then we're going to do division or multiplication, and then we do addition or subtraction. But I'll cover that in more detail, hopefully a little bit later on. So 4 squared times 2, that would be 16 times 2. I do this bit first because it's an indice, and in BIDMAS, it's the first thing that comes up. 16 times 2 is 32. Then we've got 3 squared times minus 7. Again, I'm going to work out 3 squared first. So that becomes 9 times minus 7. And remember, we're multiplying by a negative. So 9 times 7 is 63. So 9 times negative 7 would be negative 63. Then I've got 4 squared plus 1 times 5. This is where BIDMAS is going to be really important. So BIDMAS, what am I going to do first? The indice, which is 4 squared. So that becomes 16 plus 1 times 5. Then this is the part that catches everyone out, because most people would be like, okay, so I do 16 plus 1, which is 17 times 5. But nope, we have to use the order of operations. Everything we do in maths, we have to use BIDMAS for. So division and multiplication are the next thing that come up. So I'm going to have to do 16 plus 1 times 5, which is 5. And then I can do 16 plus 5, which is 21. For the next question, you've got similar kind of thing going on. 3 plus 4 times 3 squared. We're going to do the indices first. I'm going to rewrite it as 3 plus 4 times 9. The next thing I'm going to have to do, because multiplication always comes before addition or subtraction in terms of which order I do things in. So I'm going to have to do this bit first. 4 times 9 is 36. So that would become 3 plus 36, which is 39. Again, I've got a slightly trickier one. So 5 squared plus 4 times 3 squared. So I'm going to say 25 plus 4 times by 9. I work out the indices first, but I rewrite the calculation in exactly the same order. And 25 plus 4 times 9. The next thing I need to do is the multiplication. So that's going to be 4 times 9 is 36. So that's going to become 25 plus... Is it that? Yeah, it's 36. And then 36 plus 25, I can just use column addition. 6 plus 5 is 11. 3 plus 2 is 5. Plus 1 is 6. So that's going to be 61. And then a nice little challenging one with a negative number. So hopefully we've remembered the rules. So a negative times by a negative is always going to be a positive. So this bit is where it gets a little bit tricky. So don't worry too much about this, but the 8 is being squared. So because we do indices first, this would actually be minus 64, because there's a difference between, and maybe we don't need to do this so much just yet, but minus 8 squared means that 8 is being squared and then it's being multiplied by minus 1. Minus 8 in brackets squared means the whole negative is being multiplied. So minus 8 squared without the brackets is going to be minus 64, because 8 squared is 64 and then it's got the minus. But minus 8 in brackets squared is minus 8 times by minus 8, which is positive 64. So that would become minus positive 64. And minus 64 minus 64 is going to be minus 128. If that confused you, don't get stressed about that. For the majority of the time, it's going to be pretty obvious. It's just, yeah, actually don't worry too much about this, but think that when you've got something like minus 8 squared, that minus 8, the first order of operation is the indices, and minus 8 is technically minus 8 times by, is minus 1 times by 8, but let's not worry about that bit too much. That's just a extra bit if you get a complicated question with a bracket and a non-bracket square number. Otherwise, just assume a negative times by a negative is a positive. Okay, so now we've got square roots, and a square root is the inverse, or like the opposite of a square number. So let's think back to our square numbers again, and let's say we've got 4. Okay, so this is 4 because I know that 2 times by 2 makes an area of 4. Now the square root sign looks like this. So what I want to do is go through that area, and I draw a little diagonal square root, and everything that that diagonal touches I'm going to colour in. So the area is 4, so the square root of 4 is going to be 2. Let's try it again with 9. So I know that 3 times 3 gives me 9. So that's 3 times 3, and it gives me an area of 9. Now I want to figure out what the square root of 9 is going to be. So let's draw the square root through here. And 1, 2, 3. The square root of 9 is 3. So if square roots are something that confuse you and you're not fully understanding them, then I would really encourage you to draw these out, draw the little roots so you can visually see what the square roots are going to be. But essentially, if I think to myself, 3 squared is 9, the square root of 9 is therefore going to have to be 3, because the square root is essentially asking what number times by itself gives me this number. So if I know my square numbers, then getting the square root should be pretty easy because it's just the opposite. So just a quick example, we've got, let's say, just do all the square numbers, 1, 4, 9, 16, 25. So the square root of 1 is going to be 1, because 1 times 1 makes 1. The square root of 4 is going to be 2. The square root of 9 is going to be 3. The square root of 16 is 4. The square root of 25 is 5, and so forth. To double check, if you're like, okay, what could the square root of 36 be? Well, let me think to myself, what number times by itself makes 36? Oh, that's 6. So square roots are going to, if you're being asked to calculate them on a non-calculator, they're going to be a number between 1 and 12. So just try out some numbers and multiply them if you're getting really stuck. But hopefully you can memorize these. So the square root of 25 is 5, because I know that 5 times 5 makes 25. The square root of 64, well, that's a little bit of a higher number, but I know that 8 times 8 gives me 64. So the square root of 64 is going to be 8. The square root of 121 is 11. The square root of 144 is 12. And then I do 12 take away 5 squared. So 5 squared is 25. So I'm going to have to do 12 take away 25. And that's a little bit tricky. But another way we can do subtractions with negatives is, let's have a look at what's happening. I'm starting at 12 and I'm taking away 25. So a helpful thing is to think about, where am I crossing the 0 line? So if I did 12 take away 25, well, that's me taking away 12. So 12 take away 12 would take me to the 0 point. And then if I did 20, the difference between 12 and 25, 25 and 12 is 13. So that would be another 12 plus 13 gives me 25. So minus 12 minus 13, that's a total gap of 25. So therefore 12 take away 25 is minus 13. But this is a very tricky one to come up. If it was on a non-calculator, it might come up on a calculator. But that's just one way to visualize it, and that's not the best example because it's a big number. So let's try and do another little explanation. So if I had 3 take away 6, okay, I've got 3 and I'm taking away 6, and I want to think about where the 0 line is. So I want to have a total of minus 6. So if I did 3 take away 3, that takes me to 0. And then 3 plus what gives me 6? Well, another 3. So I'm going to have to take away another 3. So from 0 to minus, if I'm at 0 and I'm taking away 3, I'm going to get to negative 3. Not the best explanation, but it's not the key point of focus here. So don't worry too much. Just it will likely be like an easier thing. Okay, so square root of 49 is 7. 4 squared is 16. And then a minus and a minus come together to make a plus. Okay, so I just work out each part individually. And I do the indices first in square roots. So anything like this or this is an indice. It's the I in BIDMAS. So 7 plus 16 plus 9. I'm I'm going to do 16 plus 9 first because it's easier. So I don't have to, you can do it in whatever way you want to. It's just adding 9 is the same as adding 10 and taking away 1. So 16 plus 10 is 26, take away 1 is 25. And then 7 plus 25 is 32. Okay, for the next one, I've got quite a lot of indices, so I'm going to have to work those out first. So 5 squared is 25. I keep everything as it is. I'm just working out the indices. And the square root of 36 is 6. Okay, so all I've done is worked the value of these out. Then I need to think to myself, BIDMAS, what's the first thing I'm going to do? I'm going to do the multiplication. So that would become 4 times 6 is 24. So that would become 25 plus 24, which is 49. Then another one. So I've got 6 squared, which is 36. Take away 3 times by the root of 16. The square root of 16 is 4. So once again, let's look at what I need to do first. Well, multiplication comes first before subtraction. So it'll become 36 take away 12, which is 24. And the last question, I've got 8 squared, which is 64. Take away minus root 9. So the square root of 9 is 3. And then when I've got 2 negatives, taking away a negative is the same as adding. So 64 plus 3 is 67. Okay, so in this question, we're going to be estimating answers to square roots. Now, if you're asked to estimate, that means don't actually work out the actual value. Use some knowledge in order to make a calculated, educated guess. So this is going to be on a non-calculator paper, and it's going to require us really knowing our square numbers off by heart. So let's write the square numbers. So we've got 1, 4, 9, 16, 25, 36, 49, 64, 8 times 8, 9 times 9 is 81, 10 times 10 is 100, 121, 144. Okay, that's my square numbers. And if you've got a question like this, then I would probably encourage you to just write your square numbers out. And then what we need to do is decide between which 2 square numbers this lies. So the square root of 8 lies between the square root of 4 and the square root of 9, because 8 is between 8 and 9. So now I want to think to myself, what's the square root of 4? The square root of 4 is 2. The square root of 9 is 3. So that tells me that the square root of 8 needs to be somewhere between between 2 and 3. And the square root of 8 is a lot closer to 9 on the number line. So I'm probably going to guess something like 2.8 or 2.9. Because it's an estimate, it doesn't matter exactly what it is, you're just estimating. But if we just think about a number line, you've got 4 here, you've got 9 here, 5, 6, 7, 8 is over here, which is way closer to 9. So if the answer here is 2 and the answer here is 3, you know that it's going to be somewhere that it's a lot closer to 3. And the halfway point would be 2.5. So as long as you guess something more than 2.5, you'll be fine. But really, even if you did this working out, that's a really great sign. Okay, so all of this, knowing your square numbers. Now the square root of 10, well, the square root of 10 is in between the square root of 9 and the square root of 16. So again, I'm like, okay, I know the square root of 10 lies between these 2 things. So let's figure out what the square root of these numbers is. So the square root of 9 is 3. The square root of 16 is 4. And 10 is a lot closer to 9. So I'm going to say that the square root of 10 is something like 3.1. Again, if you had a number line, 9 is here, 16 is there. You've got 10, 11, 12, 13, 14, 15. So 10 is way closer to 9, or the square root of 9 in this case, than it would be to 16. And that's why it would be 3.1. Okay, and then we've got the square root of 41. So where would that be? Well, 41 is between 36 and 49. So that's what I'd do here. So I've got the square root of 36 and the square root of 49 here. And I've got the square root of 41. So the square root of 36 is 6. The square root of 49 is 7. So the square root of 41, 41's kind of halfway there. So 6.4 to 6.6 would be absolutely fine. Anything around that area. Then we've got the square root of 57. So 57 is less than 64 and more than 49. So I'm going to put it here. So I want the square root of 49 and the square root of 64. Square root of 49 is 7. The square root of 64 is 8. So therefore the square root of 57, which again that's 8 above 49, and it is 7 below 64. So it's pretty much the halfway point. So something like 7.5 would be great. But again, anything kind of in between those numbers will be fine because it's an estimate. It's just showing the awareness that you know that it has to be between a square root to certain square numbers. Okay, then the square root of 91, where's that? That's over here. So I'm going to write the square root of 81 and the square root of 100. The square root of 81 is 9 and the square root of 100 is 10. So I know that the square root of 91 is going to be somewhere between these two. So again, 9.5 would be absolutely fine because it's roughly halfway. We're not looking for exacts. You can double check it on your calculator. We're looking for an estimate. So just roughly what it would be. And that's how we do something like this if we're trying to estimate a square root, estimate the answer to a calculation. Okay, now we're dealing with the cube numbers, which are kind of like the square numbers, but a 3D version of them. So a square number means a number multiplied by itself, okay, which is written like this. And that's a square number because it's multiplied by itself twice. That's why the little 2 is there. So that's a square number. And then a cube number is when a number is multiplied by itself 3 times. So that's why there's a little 3 over here. So that would be how I work out a cube number. And just like the square numbers form a square, the same things happens with a cube number. It's a little bit more difficult to draw, but just as fun. So let's have a think. We've got 1 times 1 times 1 is 1. And let's try and visualize this. So if this was a square, we'd have 1 times 1. Make it a cube, so make it 3D. And what would the volume be? Well, it would be 1 because 1 times 1 times 1 is 1. So what would I do for 2 cubed? Well, that's 2 times 2 times 2, which is 8. So 2 cubed is 8. And similarly, you've got 2 by 2, and then another, oh, that's not a very good drawing, but you get the picture. And then you split all of the, so it's a 2 by 2 cube. So you'd get, ooh, 1, 2, 3, 4, 5, 6, 7, 8. Because this cube and that, it's a little bit harder to demonstrate with cubes, but you get the picture. If you actually have any like multi-link cubes at home or in school, you can actually build it and see it visually. Then we've got 3 cubed. So 3 cubed means 3 times 3 times 3, because this number here tells you how many times a number is multiplied by itself. And again, let's see if I can, maybe I'll do it here. Okay, this will be the last one that I'll demonstrate. So that would be 3 by 3 square. So that's an area of 9. And then each of those are multiplied by 3 to form this not very artistic, but still top score for effort cube. So that would be 27 cubes in total. So if you think about it, the front bit is this. This is like 1 cube. So 1, 2, 3, 4, 5, 6, because it's a 3D thing. And then you've got 7, 8, 9, well, you can't. So basically, you've got 9 at the front, and the way volume is done is like it's a slice of cake, and whatever's at the front, there's however many, whatever the depth is multiplied by it. So at the front, you've got 9 cubes, and you've got 3 lots of them, so you've got 9 plus 9 plus 9, which is 27. Remember that a repeated addition is the same as multiplication. Okay, now let's go for 4 cubed. So 4 cubed is going to be 4 times 4 times 4. 4 times 4, this is where it gets a little bit trickier because the numbers get bigger. 4 times 4 is 16. And then 16 times 4, we can just use column, just use normal multiplication. So 4 times 6 is 4, 24. 4 times 1 is 4, plus the 2 is 6. So that would be 64. Okay, so 4 times 4 is 16, times by 4 again is 64. And that's how we work out our cube numbers. 5 times 5 times 5 is going to be, 5 times 5 is 25. And then 25 times 5 is 125. I'm not going to do the multiplications for you because you can do them yourself. 6 times 6, 6 cubed means 6 times 6 times 6. So 6 times 6 is 36. And 36 times 6 is 216. 7 cubed is 7 times 7 times 7. 7 times 7 is 49. 49 times by 7 is 343. Now, I would say these are the key ones that you need to remember. So 1, 8, 27, 64, 125, 216, 343. There's not that many numbers. And also just think to yourself, okay, what number times by itself 3 times will give me this? That's how we know cube numbers. There's not going to be that many. You only really need to know them up to 10, I'd say. And probably you only need to know the ones up to 7 off by heart. And then 10 is an easy one because it's 10 times 10 times 10. 10 times 10 is 100. And 100 times 10 is 1,000. So you can try it out. If I were you, I would similarly draw this out, memorize your cube numbers, draw the little cubes out as well, and do that as many times as you need to in order to memorize your cube numbers, because you do need to know them off by heart. They're going to keep coming up, and if you don't know them, it's just going to be having to relearn them over and over and over. Whereas if you learn them now, you'll know them for the rest of your life, or at least the rest of your GCSE career, and it'll just make your life so much easier. Okay, so that's the cube numbers. Okay, so now we are looking at cube roots. So just like with the square numbers, the cube roots are like the opposite. So let's see if we can think about this, maybe with a 2 by 2. So here I've got a 2 by 2 cube. So split it up. There, beautiful. Okay, so 2 cubed is 2 times 2 times 2. And I know that 2 cubed is 8. But once again, the cubed root sign, it looks like this. It's like the square root sign, but with a little 3 at the front to demonstrate that it's the cubed root. And just like with a square root, I'm going to just do a little square root going across the front face of the cube. And what do? I colour and shade them in. So I've got a cube that has a volume of 8, and the root is a bit on the front face. When you draw the little root sign. So the cubed root of 8 is going to be 2, because 2 is the number that multiplied by itself 3 times gives me 8. So it's a little bit confusing to kind of understand, but if we just memorize our cube numbers, then it makes it very, very easy. So you've got 1, 2 times 2 times 2 is 8, 3 times 3 times 3 is 27, then you've got 64, 125, and going on and on and on. Do we have any higher ones? No. So I'm just going to put 1,000 as well, because we know that the cubed root of 1,000 is 10. So the cubed root of 1 is therefore going to be 1. The cubed, actually that doesn't look nice when it's with pink. I'll just make it, there we go. The cubed root of 8 is going to be 2, because it's a second cube number. The cubed root of 27 is 3. The cubed root of 64 is 4. The cubed root of 125 is 5, and so forth. Okay, so once again, if you have a cube numbers question and you get stuck, just think to yourself, 1 times 1 times 1 is this, 2 times 2 times 2 is this, 3 times 3, and they'll come back to memory, and then you can work backwards from there. So the cubed root of 1 is just going to be 1. The cubed root of 8 is going to be 2. The cubed root of 1,000 is 10, and the cubed root of 64 is 8. Then we have a little bit of a combination just to make life a little bit more interesting. We've got cube numbers and cubed roots. So 5 cubed, hopefully you remember, 5 times 5 times 5 is 125. And then the cubed root of 27 is 3. So 125 plus 3 is 128. Then we've got 3 cubed, which is 27, plus 4 times by the cubed root of 125, which is 5. So what I've done here is I've rewritten it. Remember that I'm always going to have to use BIDMAS, so I work out the indices first, but I still write the calculation out as it is. So 27 plus 4 times 5. I'm going to have to do the multiplication part first, so that would become 27 plus 20, which is 47. Okay, next let's do the same here. Cubed root of 8 is 2, 5 squared is 25, and I'm timesing that by 3. Again, multiplication comes before addition, so I'm going to do that bit first. So that would become 25 times 3 is 75, and 2 plus 75 is 77. If you do need to do additional workings out here, that's absolutely fine. You can just do them to the side. Then we've got the cubed root of 1,000, which is 10. Take away 10 cubed, which is 1,000. So 10 take away 1,000 is going to be 990. And remember the little negative trick? It is confusing. I don't want you to try and memorize them, because when you try and memorize them, they don't make sense. But 10 take away 1,000 is going to be the same as, ooh, there's me getting so excited about the trick. I forgot to write the minus 990. So 10 take away 1,000 is going to be, think to yourself, what would 1,000 take away 10 be? And then we're reversing it on the other side. But that doesn't make conceptual sense too much to some people, so don't worry too much. This would most likely be smaller numbers if you're having to work out negatives without a calculator. Okay, and I put in a slide about BIDMAS just so that you feel super confident and we can go through this and iron out any complications. Okay, so BIDMAS is like a pyramid. Ages and ages and ages ago, people were writing maths and people were like getting different answers, because if you wrote 3 plus 4 times 7 plus 3 times 4 plus 1, like, who knows what's going to happen? Some people were doing the multiplication first, some people were doing the addition first, some people were just doing it in random order. So what happened is someone decided that we're going to have an order of operations that tells us which operation, and an operation is something like a plus, a minus, a times, a divide, a square root, a square number, or a cube number. Okay, so which operation do we do first? Just so that everyone's doing the same thing and we get the same answer. So the first thing we'd do is if anything is in a bracket. So the bracket basically symbolizes that that thing is a unit and it needs to be worked out first. So the first we look to see, are there any brackets? And that takes priority over everything. Then we've got the I. It used to be an O, I think. When I was in school, it was O, and I don't know, things change and turn and all of those things. But it represents indices, or it used to stand for O for orders. But indices, index laws, anything that's a square number, a cube number, a square root, that's an indice. Okay, so we're going to be looking for anything that is got a square number, square root, cube number, cube root. Then we've got division and multiplication, and they're on the same level. So what we do is, if there's a division and a multiplication in the calculation, we start from left to right and we do whichever one comes first. So that's the third thing we do, division or multiplication. And right at the very bottom is where you've got addition and subtraction. So if you have an addition or a subtraction in your calculation, you do that at the very end and you wait until you've calculated it. So I'll show you exactly what I mean. What we do is we copy the calculation exactly underneath. It's just we put the thing that we've worked out into it. So let's have a go and look at what happens with the first one. So using BIDMAS, I'm like, okay, there's a bracket, so I'm going to do what's inside the bracket first. So I'll write out 4 times and work out what's inside the bracket. So the cubed root of 1 is 1, so that becomes 1 plus 7. So I've worked out inside the bracket, there's an indice, so I have to do that bit first. So 1 plus 7 is 8. So the bracket then becomes 8. And then I can do the multiplication. So 4 times 8 is 32. Let's try another one. We've got brackets, so we know we're going to do those first. So that will become 3 plus, and the cubed root of 8, we've just worked on the page before, is 2. So it'll become 3 plus 2 minus 9. 3 plus 2 is the thing that's in brackets, so I worked that out first, and that becomes 5 minus 9. 2 negatives next to each other, hopefully we're remembering, becomes a positive, so that becomes 5 plus 9, which is 14. Then we've got 7 times by whatever's in the bracket now. This one's a little bit trickier because you've got a bracket and then an indice, but we work out what's in the bracket. So 2 plus 5 is 7. So that would become 7 squared because whatever's in the bracket now becomes squared. And 7 times 7 squared is 7 times 49. 7 times 49 is the cube number because 7 times 7 makes 49. So that is going to be 343. So if you've ever got a square number times by its like square root, it's going to make the cube number. Okay, then we've got another one. We've got brackets. So again, I'm going to start here. 5 cubed is 125 minus 8 plus the cubed root of 27, which is 3. Now I'm writing this out because I know I'm going to do the bit in the bracket first, and then I know I'm going to have to simplify this to find the cube root of 27, but you can write it out as many times as you want to do it bit by bit. Then I know that a minus and a minus next to each other become a plus because remember, you're taking away the negatives, taking away the cold, so it gets warmer. So 125 plus 8 is 133, and 133 plus 3 is 136. Then we've got 3 cubed, which is 27, plus 4 squared, which is 16. Take away the cubed root of 125, which is 5. So all that's happened now is I've put loads of cube numbers and cube roots together. So that's why if you had your cube numbers and your cube roots on a beautiful page in front of you, you can just look to remind yourself. So then we've got 27 plus 11, which is going to give me 38. Final one, cubed root of 8 is 2. 5 squared is 25, and then I'm timesing it by 3. 2 plus 25 is 27. 27 times 3, again, 27 times 3 is going to be... Okay, even I think I need, okay, 27 times 3 is, 3 times 7 is 21, 3 times 2 is 6, add the 2 is 8, 81. Everybody has brain slowing down at some point. Okay, so here I'm dealing with something called a Venn diagram. And a Venn diagram is just a really great way of visually representing whether anything, two things have something in common. So each circle represents what is true for each thing. So in this circle, I'm going to put all of the square numbers. And in this circle here, I'm going to put all of the cube numbers. But what is really cool is that there's an overlap here. So anything that is both a square number and a cube number goes in the intersection. That's what we call the intersection. So let's think and start crossing numbers out. 1. Actually, just to make your life easier for this question, again, let's write out the square numbers. 1, 4, 9, 16, 25, 36, 49, 64 is 8 times 8, 9 times 9 is 81. Then we've got 100, 121, 144, and I think that's all I did. Okay, then we've got the cube numbers. 1 times 1 times 1 is 1. Then we've got 8, 27. No, wait, 3 times 3 is 9. Times 3 is, 27. 4 is 64. 5 is 125. 6 is, okay, we don't need that because the numbers don't go that big. Okay, so they're your cube numbers, they're your square numbers. So 1, hopefully you recognise that 1 is a square number and also a cube number. So it's going to go in the middle. 16 is just a square number, so I'll put it here. 8 is a cube number, not a square number though, so I'm going to put it here. 125, well, that only appears, oh, what did I do? Oh, here it is. 125 only appears in the cube numbers, so I'm going to put it here. 4 only appears in the square numbers, so that will be here. Actually, we can cross them out as we go along. 144 is in the square numbers, so I'm going to put it here. 125 I've already done. 9 only appears in the square numbers, so that will be here. 49 only appears in the square numbers, so I'll put it here. 27 only appears in the cube numbers, so I'll put it here. 64, that one's cool because it appears in the square numbers and the cube numbers. Oh my goodness, did I put 4 was in both? This is what happens when you... Okay, 4 is not a cube number, so 4 is just going to go in the square number column. Apologies if that confused anyone. 3 is not a square number and it's not a cube number. So what happens if it's not part of the things that are the circles is we put it outside the circle. That's all. It just sits outside. Sadly, it doesn't fit into any of the circles, so it's going to have to be on its own outside. That sounds really mean. Okay, the same is the case for 80 though. So 3 is not there on its own. It gets a friend. Then we've got 81, which is just a square number. Then we've got 2, which is not a square number and it's not a cube number. So it's going to sit over here. And then finally, we've got 17. Okay, so that's going to be here as well. So that's how we fill out a Venn diagram. We put whatever is true for the square numbers in the square number circle, whatever's true for the cube numbers in the cube number circle, and anything that is in both goes in the intersection in the overlap. And that makes it really easy for me to know what is part of both. So for the next part of the question, it says, which numbers are both square numbers and cube numbers? I can confidently say 1 and 64 because that is in the intersection here. So yes, basically a Venn diagram is a way of showing overlapping sets, and the bit in the middle is called the intersection, and you place anything that is true for both things inside it. Okay, so we've been dealing with powers like square numbers, cube numbers, and things like that for quite a while now. Now, what you're being asked to do here is write each product, and product just means a multiplication, well, the end result of a multiplication, using powers. So I don't want to be writing this as a multiplication. I want to simplify it. So I think to myself, how many times is 2 being multiplied by itself? It's going 1, 2, 3. So that's going to be 2 to the power of 3. So just as a reminder what the terminology means, this, the way you'd say it is 2 to the power of 3. And that means 2 is multiplied by itself 3 times. So the power here, the power tells you how many times. Actually, let's write that down. The power tells you how many times the number is multiplied by itself. And that will help you immeasurably. So 3 times 3 times 3 times 3, to write it as a power is going to be 3 to the power of 4. What am I going to do here? Okay, here's where it gets a little bit trickier because I've got 2 different numbers. When you're writing powers, they need to have the same base. So this is the base, which is the big number. That is the power. Okay, so I've got 1, 2, 3, 4 lots of 3 being multiplied by itself. So that will become 3 to the power 4 times by how many 2's do I've got? Do I have 1, 2, 3. So that'll become 2 to the power of 3. So that's how I'd simplify that. You can't mix them together because it's 3 being multiplied by itself and it's 2 being multiplied by itself. So that's how we'd do that. Then we do the same for 5. So you've got 1, 2, 3. 5 is being multiplied by itself 3 times and it's being multiplied by 10 squared because there's 2 10s. Then let's do it for 2 and 7. So 1, 2, 3, 4. That will be 2 to the power 4 times by, there's 1 5 and 1 7. And the last one, we've got quite a few, so we've got 1 2 3 2s, so that will be 2 cubed times by 1 2 3 3s, 3 cubed, and then you've got 2 7s, so that will be 7 squared. Okay, so that's how we simplify powers if they're numerical, which means if they're numbers. We don't need to work out the answer. A lot of people spend such a long time working out answers because sometimes you get something like 3 to the power 15. That's going to take you forever. You don't need to work out that really big number. You just need to write it as 3 to the power 15. But yeah, that's how we just simplify powers. Okay, so these questions sometimes, I don't know why, but people just get really confused by what they mean. So I'm told to draw a factor tree for each of these numbers and write each number as the product of its prime factors. So let's try and untangle what's happening here. Product, that means basically write it as a multiplication. So product means when I'm multiplying things and it's the end result. So essentially I want to write it as 12 equals something times something times something. That's writing something as a product. So 12 is the product and this is the multiplication that makes up 12. So a product of its prime factors. So prime, oh, we haven't covered the prime numbers yet. You're supposed to know them, but we can just do a quick little recap. So prime numbers are 2, 3, 5, 7, 11, 13. Going on, there's lots of prime numbers, but for these kinds of things, these are the key things that you need to know. So a prime number is just a number that has only 2 factors, one in itself, so basically only itself, and 1 multiplies into it. So 9 is not a prime number because 1 times 9 makes 9, but 3 times 3 also makes 9. So 9 has 3 factors, 1, 3, and 9. Okay, so that's, if anything has anything else apart from 1 in itself that multiply into it, it's not a prime number. And that's why 1 is not a prime number, because sadly, the only way you can make 1 is by multiplying 1 by 1. So it only has 1 factor, which is 1. 1 is truly the loneliest number. Okay, so the prime numbers are 2, 3, 5, 7, 11, and factors are numbers that multiply to make a number. So like, it's really difficult to actually explain them apart from just showing them, unless I explain it properly, but we don't have time. So factors are numbers that multiply to make your number. So they're always going to be smaller than the number. So like, let's say 10, the factors of 10. Oh, and they also come in factor pairs. So 2 numbers that multiply to make your number. So for instance, the factors of 10 would be 1 times 10, because 1 times 10 makes 10. 2 times 5 also makes 10. So the factors of 10 are 1, 2, 5, and 10. Okay, so it's got 4 factors. So a factor is always going to be smaller than the number or the size of the number. Okay, but anyway, that is what product of prime factors means. So whenever you see these 3 words next to each other, they're always going to be said like this. It's also known as prime factor decomposition, because it's like you're taking a big number and you're breaking it apart bit by bit. But product of prime factors is how they'll ask that question. So let's have a look at what happens with 12. So I'm going to think of 2 numbers that multiply together to make 12. And the best way to do these is by using a prime number. So we've got 2, 3, 5, 7, 11 that I'm going to be looking out for. I would probably recommend just starting with 2. It just makes your life easier. So 2 times 6 makes 12. Now, when you get to a prime number, you circle the prime number, and that's like the factor tree is burnt off. It's extinguished. It can't grow any further. So then, and the reason for that is because the factors of 2, it's a prime number. If I kept going, I'd be like, okay, well, that makes 2 times 1. Well, that makes 2 times 1. And that makes 2 times 1. And you'd go on forever, and it's pointless. So when we get to the end, when we get to a prime number, we burn the tree, circle it, and we're going to use that number later. Then I think to myself, okay, let's keep this tree growing, but I've only got a leaf of 6. So what two numbers multiply together to make 6? 2 and 3. Again, 2 is a prime number, so I'm going to circle it, and 3 is also a prime number, so I'm going to circle that. So what's happened is I have got my factor tree, and now I've got it circled, which means it's extinguished, it's burnt, it's sadly come to the end of its growth, it can't grow any further. So 12 as a product, remember it's a multiplication, is going to be 2 times 2 times 3. And that's how we do writing a number as the product of its prime factors, because all of these numbers here are prime numbers and they're all factors of 12. And the reason for that is like, how can I build 12 up using prime numbers? If I did 2 times 2, that's 4, times 3 is 12. So you can double check if you've done it right by multiplying at the end. You could also write this as 2 squared times 3 if you wanted to simplify that, but we don't have to do that just yet. That's just an extension. Okay, then we've got 80. So 80, let's start with 2. So 2 is going to go there. 2 times by 40 gives me 80. I'm going to circle the 2. Then let's split 40 up. 2 times by 20 gives me 40. Then let's do it again. 2 times by 10, which gives me another prime number. And then I'm going to do it again, and that's going to be 2 times by 5. So again, always have your prime numbers written up above there so that you know when to circle. And you've got 2 there and 5 there. So we're going to say that 80 is 2 times 2 times 2 times 2 times 5. So you know your factor tree is going to come to an end when all of the branches have been circled. We could simplify that, but I've run out of space, but let's do it here. It would be 2 to the power of 4 times by 5. I'm just simplifying the numbers because 2 is being multiplied by itself 4 times. Okay, let's try the same with 200. So you've got 200 here, and you've got 2 times by 100. So I'm going to circle the 2. Then 2 numbers that multiply together to make 100. Honestly, if you start with 2, it's just dividing by 2. So it's just the easiest way to do it. And then you try 3 and then 5. So 2 times 50 makes 100. So I'm going to break that down. Then we've got 50, which is going to be 2 times by 25. And then we've got 25, and 2 doesn't go into it. So I'm going to try 3. 3 doesn't go into it, but 5 does. I know that 5 times 5 makes 25, and 5 is a prime number, so I circle it. So 200 as a product of its prime factors is 2 times 2 times 2 times 5 times 5, which if I simplify it, it's going to be 2 cubed times by 5 squared. And 2 cubed is 8, 5 squared is 25, so you could type into your calculator quickly, 8 times 25, and double check that that makes 200. Okay, so far we've learned a really cool trick as to prime factor decomposition, how to write a number as a product of its prime factors. And now we're going to learn about, and we also learned about Venn diagrams. So now we're going to learn about how to put those two skills together to find a shortcut way to working out the highest common factor of a number. So it's saying use prime factor decomposition to find the highest common factor of these numbers. So first I'm going to have to do the factor trees. So 30 is going to be 3 times by 10. Oh, actually I could have done 2. Sorry about that. Look, you don't always need to divide by 2. If you have another prime number. The point is that you want to be dividing by a prime number because then you circle one branch and it extinguishes. Then we've got 10, which is 2 times by 5. But if you did divide 2 by 15, then you would have got 3 times 5. You're always going to end up with the same answer anyway, but this is just another way. So I know that 30 is 3 times 2 times 5. And now let's do 64. So 64 is 2 times by 32. Circle the 2. 32 is 2 times by 16. Circle the 2. 16 is 2 times by 8. Circle the 2. 8 is 2 times 4. Circle the 2. And 4 is 2 times by 2. So we're going to circle those prime numbers as well. And we're going to be left with 64 equals, wow, 1, 2, 3, 4, 5, 6. So 2 times 2 times 2 times 2. I'm going to have to rub that out now. Times 2 times 2. So let's have a look at what we do when we're trying to put this into a Venn diagram. So 30 is 2 times 3 times 5. I've just put it in order. And 64 is 2 times 2 times 2. 6 times. 1, 2, 3, 4, 5, 6. So, okay, this isn't the best example actually because I don't have very many factors in common, but it will be fine for when we do the lowest common multiple over here. So I'm just going to actually write this out. We know that 30 is 2 times 3 times 5, and 64 is 2 times 2 times 2 times 2 times 2 times 2. Okay, so you've got your Venn diagram. One of the circles is going to be all of the factors of 30, and the other circle is going to be all of the factors of 64. And what we're going to do is we're going to put each number inside. So anything that is common to both 30 and 64, anything that is a factor of both of them, we cross out and we put in the middle. So 2 appears in both of them, so I'm going to put that in the middle. Now, nothing else is common, so then I'm going to put the 3 and the 5 over here, and all of the other 2s, so 1, 2, 3, 4, 5, in 64. So what I've done is I've put all of these numbers in the Venn diagram. Now, to work out the highest common factor, that is basically all of the things that are in the intersection or the overlap. So everything that's in the overlap, well, that's just 2. So the highest common factor of 30 and 64 is 2. Okay, let's try another one to see if that makes a little bit more sense. So 36 and 80, I'm going to need to work out the factors. So 36 is 2 times 18, 18 is 2 times 9, and 9 is 3 times 3. So I'm just doing this quickly because we've practiced it before. So 36 is that. Then I'm going to do the prime factors of 80. So 80 is 2 times 40, circle the 2, 2 times 20, 2 times 10, and then 2 times 5. So 80 is 2 times 2 times 2 times 2 times 5. Okay, so now I'm going to draw the Venn diagram for this. So one of the circles is going to be for 36, and the other one is going to be for 80. So anything that's common goes in the middle. So 2 goes in the middle. 2, we have it again, so that goes in the middle again. Do I have 3 in common? No, and I don't have 5 in common. So for the rest of 36, that's going to have 3 and 3. And for the rest of 80, we'll have 2, 2, and 5. Okay, so to work out the lowest common multiple, to work out the highest common factor, we're just going to multiply everything that's in the intersection. So for the highest common factor, multiply what's in the overlap. Okay, so that's going to be 2 times 2, which is 4. So 4 is the highest common factor of this. Now, what I'm going to do actually is I'm going to flick between these two sides and just use the maybe I need to just draw it out. Okay, so to work out the lowest common multiple, you've got your Venn diagram. So I'm just going to draw them out from before. So here we've got 3, 5, 2, 3, 5, 2, and then 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so the lowest common multiple is going to be everything that is inside this Venn diagram. So that's quite a lot. And for this, unless it's a very small number, you will be given a calculation. I mean, it will be on a calculator, so you can use that to work this out. So we've got 3 times 5 times 2 times 2 to the power of 5. I've just simplified that. So 3 times 5 is 15. 15 times 2 is 30. And you've got 30 times 2 to the power of 5. So 1, 2, 3, 4, 5. So 30 times 2 is 60. 60 times 2 is 120. 120 times 2 is 240. 240 times 2 is 480. And 480 times 2 is 960. Okay, so that's what we'd do for that. And then let's do the same for our next one. So we had 3322 and 225. So the lowest common multiple is going to be everything. So perhaps I should have highlighted that. You multiply everything that's in the Venn diagram to work out the lowest common multiple. So that's going to be 3 times 3 times 2 times 2 times 2 times 2 times 5. So 3 times 3 is 9. 2 times 2 times 2 is 8. And 2 times 5 is 10. I've just made it easier for myself. You can just type it into your calculator. 9 times 8 is 72. And 72 times by 10 is 720. So the lowest common multiple of 36 and 80 is 720. Okay, so there's a few ways to do lowest common multiple, and if you're working with small numbers, then there is a slightly easier way. A multiple is just a number in that number's times tables. It's like the inverse, not the inverse, but factors are always going to be smaller than your number, and multiples are always going to be larger than your number, or the value of your number. So I'm told that Madison and Edie start a cross-country race at the same time. Madison completes the first lap in 7 minutes, and Edie completes the first lap in 8 minutes. Then they both keep running. So we've got like, let's say it's, I don't know, a random race here. And that's the cross-country lap. That's the start line. So they're going to go round, and then round again, and then round again. So what's going to happen is they're going to keep running on this course. And each of the girls is going to take the same amount of time, because it's cross country, so generally you keep the same pace. So they both start at the same time. Edie finishes the first lap. So let's put 0 for both of them. So you've got Edie and Madison. They both start at 0 time. Edie completes the first lap in 8 minutes. So each lap she's going to take 8 minutes to do. So one lap is going to be 8 minutes. Another lap is going to be add on another 8 minutes, 16. The other lap is going to be 24. It's basically just the 8 times table. So multiple of a number is essentially its numbers times tables. So we've got 8, 16, 34, 24, 32, 40, 48, 56, 64, and hopefully I don't have to keep going. Okay, then we've got Madison. So actually let's do her in a different colour so that we can see the difference. So Madison, they both start at 0, but we don't, so 7 is going to be her first lap completed. So actually let's get rid of the 0 because that might confuse you. She's going to have completed the first lap after 7 minutes. Then the next lap will get done in another 7 minutes, which is 14. Then the next lap is 21, 28, 35, 42, 49, 56, and so forth. Now, what's going to happen with a question like this is that once you list your numbers times tables, you're going to notice that they have something in common. So Edie's going to keep on running, and Madison's going to keep on running, and they're both going to be like kind of missing each other. But if they run it enough times, eventually there's going to be a time where they both cross the starting point at the same time. So what we're looking for is the lowest common multiple. So the lowest common multiple is the first number that is common to both of their times tables. So let's have a look. That number here is 56 because 56 appears in the 7 times tables and the 8 times tables. So how many minutes after they start running will they pass each other again? That's going to be after 56 minutes. And how many laps will they each have done? Well, Madison will have done 1, 2, 3, 4, 5, 6, 7, 8. So Madison will have done 8 laps. And then Edie will have done 1, 2, 3, 4, 5, 6, 7. 7 laps. Okay, so that's how we do lowest common multiple in context. It is quite tricky trying to figure out what we need to do, but if we recognize that we're dealing with multiples, we just start writing out their times tables, and the lowest common multiple is recognizing what's the first number that they have in common. That's why it's the lowest and common multiple.